Does the stock market follow a weekly pattern? And are there certain weeks of the year that are more consistently bullish or bearish in the 20-year period? In this video, I'll be doing some simple R coding language to find out the answer. And yes, the answer might surprise you. We know that there are 52 to 53 weeks in a year. You know the stock market will behave more or less randomly throughout this time. But there are some traders who believe that there are some weeks that are historically more bullish or bearish. These traders are known as pattern traders, and they think they might know something that we don't. So are they right? Is there actually certain weeks that we can prove historically that are more bullish or more bearish? So let's determine whether they are right, shall we? In this video, I'm going to use R language, and I'm specifically going to use the simple R language functions so that you will be able to replicate them and modify them with whatever ticker symbol you want if you're a basic R language user. So without further ado, here are 4 simple steps for you to be able to replicate this study to find out whether there are weekly patterns in the SPY, and let's get to it. Step number 1, get data. Before we can do any data analytics, data is incredibly important. Thankfully, the internet is pretty reliable. We can get many sources of the data. So I'm going to be using the quantmod package and specifically the get symbols function. Now let's talk a little bit about the arguments of the get symbols function. Symbols here refers to the ticker symbol of the stock we want to study. In this particular project, we want the SPY. From and to arguments are the dates range where we want our data. The important note here that we need to ensure we provide the dates as a date object. So use the s.date function to convert our string into a date object. If you're completely new to R and this step confuses you, not to worry, you can just replicate s.date as you see on my screen. Another thing to note is to use year dash month dash day format wrapped in inverted commas. In this project, I'll be using 20 years worth of daily SPY prices. One important thing to note about the from date, you may have noticed that I chose to use a start date on the last day of December instead of the first day of January. This is because we want to determine how much the SPY changes in percentage terms for that week. Thus, for SPY changes in week number 1, we need the closing price of the previous week, which is week 52 of the previous year. The last argument is the SRC argument, which stands for source, and we will be using the data from Yahoo Finance. You can change this if you prefer, but Yahoo seems to work great. If you have some experience in R, you will notice that I did not assign the results of the get symbols function to an object. There is no need to do that here, because the get symbols function would already create the object SPY in your environment. From here on, all you have to do is call the object SPY to access the data you have obtained. A quick glimpse of data we got confirms that, yup, we have the data we want. Step number 2, clean the data. Those who are observant would have noticed something odd in the SPY data we got. The dates in that object are not in any column with a name. In fact, the dates are actually row names, which means that SPY is not a data frame, but a time series. Furthermore, there are 6 columns of prices for SPY. There's the open, the high, the low, the close, the volume, and the adjusted close. For the purposes of this project, we are only going to concern ourselves with the closing prices for the day. The first part of data cleaning would be to convert the row names into its own column and then select only the dates and the closing price. This can be achieved using the Tibble, Lubridate, and Dplyr packages. We use the row names to column function from the Tibble package to create a new column called date. Because the SPY object is a time series, we need to coerce it into a data frame first for the function to work. The var argument allows us to give a name for the new column that will be created. At this point, the newly created date column is just a string of characters in R's point of view. We need to tell R to treat this column as a date object. Using Dplyr package's pipe function, we will pass the results into a mutate function which allows us to make changes to the column. The ymd or year month day function from the Lubridate package allows us to tell R how to encode the date object. Mutate date equals ymd date can thus be read in human language as modify the date column from the current character class into a date class. Next, we will select only the 2 columns that matter to us, date column and the SPY.close column. All the other columns don't matter to us. While we are at it, let's rename the cumbersome SPY.close column into a simpler name so that we don't tie our tongue in knots. Just close would be much better. Let's save our work thus far into a new object and call it SPY.df, df standing for data frame. Step number 3, wrangle the data. We now have a simple data frame object consisting of a date column and a close column, but our goal is to analyze weekly SPY prices, not the daily price. Also, we want to be able to group the weeks according to the year as well. We can achieve this by first creating two new columns, a week column and a year column, which tells us which week of the year and the year itself that particular day belongs to. Thus, you can see that there are now 5 rows for week 1 of year 2000, representing the 5 trading days or Monday to Friday of that week. To get the change for the week, what we need is to take the closing price on the last day of the week, mostly Fridays with some exceptions on public holidays, and subtract the price from the previous week's closing price. Thus, what we are going to do is to filter out only those rows which are last trading day of the week, while keeping in mind that we need the year column. Using dplyer's group by function, I'm going to group our rows by weeks and years. Nothing visually happens at this step. The group by function basically places imaginary boxes on rows belonging to the same week in the same year. The filter step is where changes happen. By filtering for max date, I'm saying give me the last day within each imaginary box. Hence, what is left is the last trading day of every week or every year. What we need now is to take the closing price of the week, subtract the closing price from the previous week. To do this, I'm going to create a new column called lag. But this column is just an intermediate step where we use the lag function to push the entire close column down by a row. What this does is it lines up the week's closing price together with the previous week's closing price together in the same row. Thus, to get the weekly change, it's a simple mathematical calculation of evaluating the percentage change, i.e. close minus lag divided by close, then multiplied by 100. Let's put the results in a new column I will call perc close for percentage change in closing price. As you can see from the current data frame, the very first row carries NA in the perc close column. We don't need the first row, as it was purely an intermediate tool for us to find percentage closing price of week 1. So we are going to use na.omit to leave out the first row of data. Then select only those columns we need in our data visualization. Step, week, year, and perc close. And as a sign that we are ready for visualization, let's save our data frame as SPY ready. Step 4. Visualize the results. Now, before we go on, let's think about what we want to achieve here. What we want to do is to create a visualization where I'm going to have a horizontal axis. And on the horizontal axis are going to be weeks. On the vertical axis are going to be the percentage change. So the higher the column, for example, I'm going to be plotting a column chart. So the higher the column goes up, the more bullish that particular week of the year has been. I'm going to spice things up a little bit. For the columns that are bullish, I'm going to color it green. For the columns that are bearish, I'm going to color it red, just as a nod to the stock market colors that we see on a day-to-day basis. Let's start by aggregating the data into weeks so that we can find the average percentage change for each week. I'm going to be using the mean function here. So use group by week and then summarize to aggregate the mean percentage change per week into a new column. We will simply call mean. Now we are ready to plot. Using library ggplot2, we will pass SPY20 into the ggplot function and map the x-axis to our week column, y-axis to the mean column, and for the highlights, I'm going to map the fill color to the mean columns as well. We will add the geom column layout, and I'm choosing not to show the legend to make full use of the space on our plot. I'm going to customize the fill color with a salute to the world of finance by telling ggplot to color bullish moves as green and bearish moves as red, while assigning the black color for everything in between by adding the scale_fill_gradient2 layer. As a personal favorite, I love theme_minimal and how clean everything looks, so I'm going to add that layer to my plot. Finally, let's give our chart some proper labels with the labs layer. Since the horizontal axis still seems pretty cramped, I'm going to wrap my ggplot code in the ggplotly function from the plotly package. This would allow me to get pop-up info when I mouse over any column. Great! So that's the 4 steps done. Step 1, get the data. Step 2, clean the data. Step 3, wrangle the data. And step 4, visualize the data. So were the results what we kind of expected? Well, I'm expecting something to be completely random. Let's find out whether the pattern traders are right. So what do the results show? Well, not quite what I expected. It turns out that there are some weeks that are more bullish on average than others. For example, week 16 appears to be the most bullish week of the year with a mean percentage gain of 1.32%. Week 38, on the other hand, is the most bearish week of the year with an average of 1.78% loss over 20 years. This might imply that the pattern traders might be onto something here, And perhaps we too should be buying the SPY every week 16 and shorting the market every week 38. Or should we? You know, using mean to find the average isn't exactly the best thing to do here, because there definitely were some years that were just huge outliers, and mean is notoriously susceptible to outliers. Let's think about this a little bit. The last data that we got was in 2019. There was the dot-com bubble, which was huge. There was the Great Recession or the Great Financial Crisis in 2008, which was absolutely massive. So these two great events would definitely have skewed the result in some way if we had used mean. So in subsequent videos, what I'm going to do is I'm going to use some different statistical operators, for example like median, to find out whether this is still consistent. Furthermore, I'm not just going to use 20 years, but I'll change the durations a little bit. What happens if it was 10 years? What happens if it was 5 years? So now that you've seen the code, perhaps you can shortcut that process, you can do it yourself, and let's see what kind of data you get. And that's my video for this week. Did the results surprise you? Let me know in the comments below, right after you click that like and subscribe button. Thank you for watching.